Welcome to our lecture, Parallel Exercise Walkthrough for Week 2. In this set of exercises, I will work exercises from the book that use the same features and problem requirements in general, the same learning concepts that are assigned in each of the actual homework assignments. The idea is that in following these parallel assignments, you should be able to translate what you've learned and apply it to a very similar kind of business statement or problem statement in the queries that are assigned as the actual homework, and those will vary from term to term and week to week. The parallel exercise for our exercise number 1 this week is taken from chapter 4, Tau Distributors, exercise number 2, which asks us to list all rows and columns for the complete orders table. So we're going to be using the star operator. Select star is the key concept we're exploring here. And so let's first make sure that we're using the Tau database. And once that's set, that does not need to be repeated once you've set the database schema. So we'll use Tau, semicolon, start a new batch, and let's select star from orders. And I like to break up the line visually as our queries get more complex. It will help to keep things more readable. So with each keyword, I'm going to break that in different parts of the SQL clause that we're using. That'll become clearer while we're doing that in future. And then let's go ahead and execute that. And here is our complete result for the entire table. So all of the rows and all of the columns from that table have been returned. And of course, we can use the splitter bar to adjust the screen real estate so we get a little better screenshot for our reporting for our assignment and for better visibility. Parallel exercise number 2 is taken from chapter 4, Tau Distributors, exercise number 3. And we're going to be focusing on using a comparison operator greater than or equal to in this exercise. And we want to use that to list the names of customers with credit limits of $10,000 or more. So let's go ahead and say select customer name from customer. And let's see here. Give that a run. That gives us all of the customers. Now we've got a working query to begin with. Let's expand on that. We want to list just the names, but we want to do so for the customers with credit limits of $10,000 or more. So we need to add a where clause. Where credit limit, and here we can use the autocomplete. So once I start typing it, once it's got the from clause in there, it'll recognize that's the table. When I start to type a valid name, as soon as I start to type it, it'll give me a list of options. I can use the mouse or I can use the tab key to come down, select it, save myself a little typing, also save some typing errors so I don't have typographical errors in there. Where credit limit, and key here is greater than or equal to 10,000. Okay, so make sure that when something is, 10,000 or more, that means equal to 10,000 should be included as well as more than 10,000. So we need greater than or equal to. If we use just the greater than operator, we're going to get marked off for this exercise. So make sure that you read the words very carefully and give that a shot. And here we are. Now notice that although we are making a decision in the where clause based on the credit limit, there's no requirement that the credit limit field appear in the results. If you wanted to sanity check this, you could add the credit limit up here. And we can check and see indeed all of the solutions are 10,000 or more. Don't submit it that way though, because that's not what the problem asked for. The problem statement said just give me the customer names. But the emphasis here is that we can make our decision based on a part of the table in the where clause that is not displayed in the results. Okay, and the key thing here is the use of the greater than or equal to operator. Our comparison operators include equal to, greater than, less than, greater than or equal to, less than or equal to, and we can also use not equal to. In exercise 3, we're going to continue our exploration of comparison operators. We're also going to introduce a Boolean operator so that we can do a comparison on 2 different fields simultaneously. And the twist on this is we're going to be using a date field. So the exercise says to list the order number for each order placed by customer number 126 on October 15th, 2015. Let's build it slowly and incrementally. So let's start by saying select, and sometimes it's easier to grab everything. Select star from orders. Okay, there's everything, but we're not interested in everything. We are only interested in the order number. So let's trim that down to order num. All right, there are all the order numbers, but with no filter. Now we need to add a where clause. And one of the conditions we want is where the order date is equal to And single tick marks are important here. 2015, 10, 15, single tick mark. That's part of it, but we also wanted to make sure that these only belong to customer 126. And if we were to put temporarily our customer number back here, we would see that we're getting orders from 586 as well. So we need to add a second condition and make sure that they are both true. So to do that, we use the Boolean AND operator. So and the second clause must also be true. And in this case, we're looking for customer num is equal to 126. And that's correct. And now let's get rid of customer number because that was not required in the output. And now we have the correct solution. In exercise 4, our key objective is to make a selection based on multiple values. So there's a couple ways to approach this. In this exercise, we're going to approach it using comparison operators and a Boolean operator, and in order to join them together to make a list. We'll see other ways to address this in some of the exercises to come. In this one, we want to list the number and name of each customer represented by sales rep 30 or 45. So let's start by a select all. So here's our complete table. And then let's trim it down. We only want to have the customer number and customer name. And our where clause, the first condition we want where the rep number equals 30 or 45. Let's start with 30, get our query working, and then let's add to that. There we go. And there's our customer number and customer name for rep number equals 30 or 45. And if we want to sanity check that, we could temporarily put back in the rep num and double check to see only rep nums for 30 and 45 are being selected. They are. And then remember to remove that from the display so we don't lose points, because we should only display the specified or minimally required fields, and the problem is solved. In exercise 5, we're using a comparison operator on a varchar or string value. We want to find the item number and description from the item table where the category is not equal to puzzle. So we can do this with negation. The easiest way is perhaps to just use a comparison operator not equal to. Let's again start with a select star from item. And here's our full item table. And then let's add the where clause where category is not equal to, so everything except P, Z, L. And notice that row 5 here has puzzle. So when we rerun this, that should drop out. Row 5 now is moved forward to GME, and that's gone. And then we need to filter this down to just the values that we want. And the specifications said we want the item number, the description, and number of units. Excuse me, I'm reading the wrong problem. We want the item number and description only. Next problem, we'll work on the number of units on hand. Okay, so double check that. Yes, we want the item number, description from item where puzzle for category is not equal to puzzle. And there we are. So this can also be addressed with the not operator to create negation, and we will see that in future exercises. Exercise 6 is a little different from our other exercises in that we need to solve this twice using two different methods. So what we're being asked to do is to list the item number, description, and number of units on hand for each item that has between 20 and 40 units on hand, including both 20 and 40. So 20 through 40 inclusive. So we've got a range. There's two ways that we can address a range. One is to address it using the between operator, which is inclusive. So let's take a look at how we would do that. Again, let's start with a select star on this. And we are working with the item table. So there's our entire item table. And then we want to winnow this down a little bit. Let's start on our where filter. And so we want to say where the on hand is between 20 and 40. And sanity checking that, that is correct. Now we need to remove some of the excess columns from the display. So we only wanted the, let's see, we want the item number, the description of the item, and the on-hand count. There we go. So we can still see that that's between 20 and 40. All right, but we need to do this a second way as well. And so let's copy that query and just put it down here. And a little trick, if we haven't already discovered it, is we can select only some of the lines of code to run. So if we wanted to run the first query, we could select this one and say execute. The second one, we can select this one. So let's come in, and what we want to do here is we need to change this. So rather than using the between operator, we're going to use comparison operators and a Boolean. And so to make it more readable, let's put some parentheses in our condition. So where the first part is true and the second part is true. So we've kind of put our parentheses there ahead of time. It makes it more readable. So what's the first condition? The first condition is that the on hand, oops, there we go. Include that in the condition where on hand is, and it must be greater than, but it's inclusive. So remember that equal sign, greater than or equal to 20, and on hand is less than or equal to, remember it's got to be inclusive, the between is always inclusive, 40. And let's run that. And, oh, I ran the whole thing. So we got two results here, and you can see that the results of both the queries are identical. And for demonstration purposes, let me come back here and show you that if I select only one, we can run them one at a time. So we can run one, we can run the other, or we can select nothing and it'll run both of them, in which case it splits our results screen, which is kind of neat. And we can compare the two. In exercise 7, our key concepts are to use our first calculated field, and we're also going to use the as operator to create an alias or new title for that field. And we can alias any calculated field so we don't get a big ugly formula as the expression in the field header, but we can also alias other columns. So if we have columns that are named rather cryptically in the database schema, and we want to make that a little clearer in our reports and our interactions with the end user, we can use the as to rename them to something that's maybe a little more meaningful. All right, so in this case, we want to list the item number, description, and on-hand value, and the units on hand time the unit price is what we're going to use to calculate the on-hand value of each item in category toy. Okay, so let's take a look at that. This is going to come out of our item table. So let's start with a select star from item. Great. So there's our full item table. And what we would like to add to this is beyond all the existing fields, we want to have a calculated field, which is going to be on hand times the unit price. And let's see, what is our unit price field? It's just called price. Okay, and let's rerun that. And now we see that we have the on-hand value at retail, what the price times the quantity on hand would come out to. And notice that there's no column name here for the calculated field by default. So what we'd like to do is make that a little friendlier and easier to identify. So let's add the as keyword, and we'll give it a name here. And let's call this as the on underscore hand underscore value. And if we use underscore so there's no spaces, we don't have to express it as a string, so we don't have to put that in quotes. And there's the title, our on-hand value. Now, we don't need all the extra fields here, so let's get rid of the star and let's trim this down to just the fields that are required for the exercise. So we wanted the item num, and let's see, the description, and the on-hand value. So let's give that a run. And let's take a quick look. If we come over to our TAL database and look at the TAL customer table, this is the items table. And our columns, item num should be there. Okay, so the problem here, this is subtle, but it's important. So item num is a valid column name, even though it's saying it's not a valid column name. And the reason it's confused comes out later in the line. Notice that I'm missing a comma here, and so the parser is not parsing the field names correctly. If I add in the comma, then all the previous problems go away, and execute it. And now we have only item num, description, and on hand times price, and that's going to be labeled on hand value from item. And then we have one other thing to add. This is doing generally what we asked for, except it said only for the category toy. Okay, so let's temporarily, so we can sanity check our work, add back in the category. And we will see that we have all kinds of categories here. We want to get only toys, so let's add that to our filter, our where clause, where category equals TOY. Run that, and now we're getting only the toys, and then let's remember to trim off the display, the category name, which is not part of the requirement. And there's our solution. Our key concepts for exercise 8 are very similar to exercise 7. We are again creating a calculated column and aliasing that with a column name using the as clause. The difference here is we're now going to use that calculated field as part of the where filter. So we can indeed use mathematical expressions and calculated fields in the where clause as part of the filter. So the exercise here says list the item number, description, and on-hand value for each item whose on-hand value is at least $1,500. So $1,500 or more. So it's going to be a greater than or equal to. That's your clue there. That's inclusive of 1,500. So remember that. Assign the name on-hand value to the computed column. Okay. So again, let's start with a select star from item. Here's our item table, and we need to add in a calculated field, and it's going to be on hand times price. So there's our calculated field, and we want to give that a name, and we're going to alias that field as on hand value. But we also need to filter by that. So we're going to repeat that. I'm going to come up here and copy that expression. Control C will copy it to my clipboard. I'll add the where clause. I'll paste it back in. And sometimes it's easier for your eye to follow if you group calculations in parentheses. Not necessary in this case, but always to be on the safe side. When you throw the parentheses in, it makes it a little bit easier to parse and to read. And as you get into more complex combined operations, order of operations, sometimes you will need to make sure you put the parentheses in to conduct the order of operations as you intend for the formula. So remember PEMDAS, please excuse my dear Aunt Sally, which tells you that the powers, exponentiation, parentheses, exponentiation, multiplication, division, addition, subtraction is the order of operations. So you'll recall that if you have multiplication and subtraction going on in the same line, it's going to do the multiplication first unless you put parentheses around to group it. So never a problem to put the parentheses in to make sure you're explicit about what you want to have happen. And again, I think it's easier for your eye to follow. All right, so we have price times on hand. So that's our on hand value, and we want to filter to only those that are greater than or equal to 1,500. And let's give that a run. And yes, I see that the sanity check is working on hand value. All of these are greater than 1,500, but I also see that I'm still grabbing the star, so all table fields. So let's go in and drop that out and filter this down to only those fields that we want. Going back to the original problem statement, we said list the item number, the description, and then our on-hand value, and execute, and there's our solution. Here we are at exercise 9, and in a previous exercise, we were working with lists constructed by using comparison operators in conjunction with Booleans. And we've seen how to do that with ranges, we've seen how to do that with this and that and the other, etc. In this case, we're going to see how to really manage lists natively. Lists are supported by SQL. And so we use the in operator to determine if there is membership within a list. So in this case, the problem states use the in operator to list the item number and description of each item in category GME or PZL from our item table. So let's start by constructing the star query. So select star from item, and there we are. And then let's work on our filter first. So we want to say where category is in, and we denote in SQL a list with comma separated values in parentheses. So we'll put our list in here. In this case, there's only 2 items in the list, quote GME, end quote, and quote PZL, end quote, but we could add commas and continue the list on for whatever number of things we wanted to have in our list. Let's see if this is working. And it is. Sanity check, we should see only game or puzzle, and we do see only game or puzzle in our result set. So that filter is working, and now we need to reduce the output to only the required fields. Again, don't want to lose points by getting the logic right, but the display wrong. So let's reduce that. We wanted what? We wanted the item number and the description. And there it is. So, and again, just to emphasize, notice that our display does not have to include a display of the field that we're operating our logic on in the where filter. So this is kind of a common mistake for new students and people new to SQL. They have it in their head somehow that if we don't have the field that we're operating our logic on in the display, that it won't be included and won't work. That's not true. That's simply a matter. This is the select part is what we output to the screen or console or to our, print to our report. The where filter can operate on any valid expression or criteria that's included somewhere in the from clause. And since the item table includes the category, then we can certainly operate on it irregardless of whether we show it in the display. And let's run that again. And nice, there's our result. For exercise 10, our key concept and learning objective is to use the wildcard operator along with the like keyword. So those will be used in conjunction, and we're going to use that to solve this problem. Find the number and name of each customer whose name begins with the letter capital C. Okay, so let's start by grabbing all the customers. Select star from customer and give that a run. And if we visually inspect it, There's cards and more that begins with a C, so we want to see that. And Crest Store and Cricket Gift Shop, so we should see all of those. So let's see if we can use the filter in our where clause, excuse me. And we want to find the list where the customer name is like this expression. Starts with C, and then the wildcard operator can represent any number of characters or spaces. So if it starts with C, so if we wanted to find something that ended in C, we would put the wildcard operator ahead of it. So starts with anything but ends with C. If we wanted to have any name that contained C, we could do it this way. Starts with anything, somewhere in the middle is at least one C, and then ends with anything. But in this case, we want only C wildcard. Be careful with using wildcards. They can lead you to logical errors. So let's say that we wanted Charlie as the first name, and we happened to know that the only name starting with C was Charlie. You could do something like C wildcard and get it, but you will see here that this would lead to other names as well, logically possible, even if they don't exist in the data set at that time. So for example, let's say I put in CR here. So I only get Cricket and Cress, or I put CRI. If I get sloppy, so let's say at some point in time, the only C name I have is Cricket Gift Shop, I could get sloppy when the data set doesn't have all that. Just give me all the C names because I know it's only going to be Cricket. That requires my specialized advanced knowledge of the data set only possessing a certain thing. Over time, that data is going to change, and so this query would, over time, let's say we then go add Crest Store and the other C name, all of a sudden I'm getting more than I expect. So you have to be careful you don't make the scope too broad when you're using wildcards. That is a pet peeve of mine. I'm a stickler for it. It's something I will be looking for. So if you are careless or overly broad in formulating queries using wildcards, expect to lose points. So we need to use those with some precision. So here we are, select star from customer, where customer name starts with C, and that is working correctly. And let's look at our original requirements, and we're still displaying too much. So we needed only the customer number, the customer name, and that's it. And there's the solution. Exercise 11 introduces the order by clause, so we're going to sort our results. And the problem here says list all details about all items and order the output by description. So let's start with a star select star from items. And there they are. And now There's no where filter, but we do have an order by clause. So let's order by description. Now, we need to specify whether the sorting is going to be ascending or descending. So if we put ASC following that, then description, if we spell it correctly, there we go, let's just replace that. Then the description should be alphabetical ascending. All right, so this goes from classic railway set down to Zaberkasten brain teasers. Okay, so let's change this to descending, DESC, and we can see it sort the other direction. And if it is omitted, what is implied is the natural order, which is ascending. So if we omit the ASC or DESC, it works and it sorts ascending. All right. In this example, we're only sorting by one criteria. There's no subsort. We'll see what happens when we have multiple sort keys momentarily. Exercise 12 continues our exploration of sorting. Now we're going to introduce the idea of sorting by multiple keys, and within a group of things sorted by the first key, known as the major sort key, we can then do a subsort. So you would do this if you were sorting by last name and then first name. So for example, you might have two people named Smith, and one is Jane Smith and the other one is Bob Smith, and so you would sort secondarily by first name. So within the group of Smith, Bob would sort above Jane alphabetically. So let's go ahead and see how we'll do that. And our problem statement here says, list all details about all items. So let's start with that. Oop, item. So there's our complete item table. And it says, but order the output by item number within storehouse. So within the storehouse group, so our first order by is going to be the storehouse. So let's see that. Okay, so are we sorting correctly on storehouse? Yes, we are. Storehouse 1 comes before storehouse 2, comes before storehouse 3. And so let's add the secondary sort key. And within that, it's going to be item number. So if you take a look within storehouse number 1, here's item number 1, item CD33, storehouse 1, FH24, item number 1, Kale78. That's not terribly interesting because they happen to be in alphabetical order. Let's see if any of them in item number, in storehouse number 2 are out of order by item number. Let's see. So TR40, TW35, KD34 should have sorted above the T's when we add that. So let's watch KD34 to see if that now happens. So let's go ahead and add in our item num as the secondary sort criteria. and rerun it. And if we scroll down, where did KD34 go? KD34 in item in storehouse number 2 is now after item D because DR67D comes before K, but it's above TR40 and TW35. Good, so both of those are now working. The interesting thing is that these keys, now we haven't specified ascending or descending, so those are both ascending. We can independently decide whether one or both of them need to be sorted differently. So we could sort, for example, storehouse descending, but leave item number ascending. So this will give us storehouse 321, but with the item number still in alphabetical ascending order. Let's see, is that true? So we started out, yep, storehouse number 3, but if we look at the item number, A comes before D, so that is true. We could also make it descending, descending. Run that again. And now for storehouse number 3, we start with the N's and go backwards to the K's, to the F's, to the D's, to the A's. So that's working. Or the other way around. We could sort the first one ascending and the second one descending. And so now we're back to storehouse 1, 2, 3 order. But within those, we'll start at the end of the alphabet. So storehouse number 1, the alphabetically last entry there is MTO3, goes backwards to K, to F, to C for storehouse number 1. And again, if we omit the sort expression, the default is ascending. So if I take ascending off, it's not going to change anything. It's still storehouse ascending, item number descending. And so the order in which we put these fields determines which is the primary sort key and which is the secondary. And if we add more sort keys, tertiary, quaternary, and so forth, you can have many, many sort keys out there. Generally, 1 or 2 is what we'll see most often, but more are possible. All right, so this is still doing a select star. Let's go ahead and get rid of the descending because it didn't say anything about descending. The natural sort order will be ascending for both. And our problem statement says select star from item. Oh, so it wants all of the items, so we're done. We don't have to further filter the display. Select star from item order by storehouse and item number, and execute that one last time. And there we go. Select star from item order by storehouse item num, and there's our solution. Exercise 13 will introduce us to our first aggregate operator. We're going to use the sum operator or sum function. And they're called aggregate operators because they are ordinarily used with groupings. For very, very simple queries, we can use them without doing a grouping because implicitly the whole query is one group. Okay, we'll see what we mean by groupings as we work into the aggregate functions and the group by clause coming up in more detail. So this will be very simple use of aggregate functions. And the problem statement says, find the total of the balance for all customers represented by sales rep 15 who have balances that are less than their credit limits. Wow, there's a lot going on there. So let's break this down. Let's start, as always, with a select star. So let's say select star from customer. All right, so let's parse this. It says find the total of the balances for all customers. So we need to say sum balance. And there's the grand total for the whole table for all customers, but we need to filter this a little bit more. Okay, so from customer, but customer where? What customer? For customers who are represented by rep 15. Okay, the number went down, kind of sanity checks that. If we wanted to, we could come up here and say star, and let's just go ahead. We can put double dash is the comment indicator, and so that turns the rest of that line into a comment that's there for internal documentation, but will not be executed. So if we run that, we see, yes, now we are only getting rep 15, and we can drop out that selects the star part and get back to the sum balance. So now we believe we are actually getting the total for only customers repped by rep 15, but wait, there's more. It says represented by rep 15 and have balances that are less than their credit limits. So we need a logical and. There's another condition here, and another condition applies. And that condition is the balance is, and it said less than. It did not say less than or equal to, so we need to pay attention to the detail, their credit limit. Okay, and so we think we've got it. Let's see if it parses and runs correctly. It does. The number went down again, which we'd expect with further filtering. And let's sanity check that. So let's drop the balance out and put the star back in. And so, are they repped by rep 15? They are. Is the balance in each case less than its credit limit? 1210 is less than 7,500, 4 grand is less than 10 grand, $935 less than $7,500. So that appears to be working. And so having sanity check that, I think if we get rid of the comment and the star and put that back in, then there is the answer to the total of balance for all customers for rep 15 whose balance is less than their credit limit. Okay, does that meet our requirement? Let's double check. Find the total of the balances for all customers represented by sales rep 15 with balances that are less than their credit limits. Good, always worth taking a moment to double check that we've complied with the actual problem statement, and we have. It's running fine, so there's our solution. In exercise 14, we're going to learn about our next aggregate function, which is the minimum operator, or min. And min will produce the lowest value in an expression or range for the field selected in the query. So in this case, our problem statement is, what is the price of the least expensive item in the database? Okay, so we're going to, again, start with select star from item and run this, and we can see the various prices. If we wanted to take a peek in advance, if you're thinking fast on your feet, you would realize you could say order by price, and let's make that ascending and run it. So the very first result, 1095, should be pickup sticks, KL78. Okay, so what we want to do is use the min function to return only this one row. Okay, so let's see how we would do that. So return it to what it was. Start with everything. There's the whole table. And we want to get the min price from item. So here's our min operator, and in the parentheses for that expression, the minimum what? The field we want is price. And let's run it. And there it is. The price for pickup sticks was $10.95. That was the lowest priced item in the table. So that's it. So we'll wrap up this assignment set with exercise 15, which takes us back into parsing strings with the wildcard operators. And the key concept here is to use the wildcard operator at the beginning and or end of a string. And so the situation here is we want to list the item number and description of all items that are in the puzzle or toy category and contain the word set in the description. So again, let's start with the simplest case. Let's select star from item, give that a run, and if we scroll through the descriptions, we see there's a cribbage set, there is a woodblock set, and then are either of those puzzles or toys. So if we have games that are sets, then we wouldn't want to include those. Okay, but let's work at it a little at a time till we get it filtered down. So select star from item. The first thing we want to do is we want to say, hey, filter that to only where the description, and remember that our wildcard operator works in conjunction with the keyword like something. Okay, and we want it to start with anything, and we want it to have the word set in it, S-E-T, and ends in anything. So the word set could apply anywhere in there. Now, we need to think about this. It might also be correct, depending on what our thinking is, to say space set space. And that would have the word set apart by spaces within it, because SET, like asset, the word asset, it contains the word set, and you wouldn't necessarily want to include that. So just something we need to think about. Would this be a better answer with um, space set space or not? So let's give that a try. Oops, and I've forgotten my trailing quote. Thank you very much. Give that a try. And so in these cases, SET is always its own separate word. In this case, we're working with a database that is set for collation to be not case sensitive, so it doesn't matter whether we use upper or lower case. Some databases will be picky about that. That also bears some thought. And it looks like space set space gives us a good answer. Does it? Do we pick up anything this way without the spaces? Doesn't seem to make a difference in this case, so I'll leave it to you. I'll accept either solution as a full credit answer, but I want you to be thinking about that, because in future, in business, the real world, it is going to matter whether you get correct or incorrect result sets or extra values in your set that you didn't want, or you miss values in your data set that you should have gotten. Okay, so let's leave the filter there and look back at the rest of our requirements. So it says list the item number and description of all items that are in the puzzle or toy category and contain the word set. So I see there's a game here. Okay, so let's add an additional filter, and category, and let's use our in operator and a list to do that. We've seen a couple different ways to do this, and in is a good operator when the lists are more than 2. This happens to be just 2, but we might expand that in future. So let's use that, and then our query will be ready to grow. It'll be easier to deal with growth or modification in the business requirement in future. Real easy to expand the list. Puzzle or toy, and we should see cribbage set disappear, and it does. Good. Okay, and now what else? So let's read the instructions again. List the item number and description. So instead of select star, let's get the item number and the description of all items that are in the puzzle or toy category and contain the word set in the description. I think that should do it. And there we are. And again, if you are looking at it and you're not quite sure if you got it, you can always go back and temporarily add back in the field to see if your filter is working. Yes, it is. Don't forget to take that off so you're displaying only the output that is required for the problem statement. And there's our solution. This concludes the lesson.